So set this equal to 0, subtract the 48, x squared plus 16x, and we're missing some number, equals negative 48. Now, we want to factor this into a perfect square. What would the factor be? Plus 8. And what's the perfect square? 64. Well, if I add 64 to one side of the equation, I need to add it to the other side in order for the equation to remain in balance. So this equals 16. This one's going to work out to be a nice number. We square root and square root. X plus 8 equals, close, plus or minus 4. Then I subtract 8, and I get negative 8 plus or minus 4. What is negative 8 plus 4? So we get x equals negative 4 and negative 12. Could I have factored this one? The answers are whole numbers, so yes, it would have factored. Okay. For the next one, add the 15. X squared plus 10x equals 15. What is my factor? Plus 5. And if I square that, what's my perfect square? 25. So now 15 and 25 gives me 40. 40 is not a perfect square, so this one's going to have a square root in it. Square root, x plus 5 equals plus or minus. 40 does not come out evenly, but what goes into 40? 4 and 10, 2 and 2, 2 and 5. Can I bring anything out? Set of 2's. What stays on the inside? 10. Then it's just root 17, right? If nothing comes out, then it's just whatever's there. If everything comes out, then there's no square root. Then I subtract the 5, and I get negative 5 plus or minus 2 root 10. That's what we refer to as an exact answer. We could plug that into our calculators and get the decimals. You could even graph the quadratic and use the second calc root to find the decimal values. And sometimes the decimal values are nice. For instance, if you're looking for, remember those story problems we did where the guy jumped and hit the water? Well, if I said, oh, he hits the water at negative 5 plus 2 root 10 seconds, that doesn't mean anything, right? So we would want the decimal answer. But a lot of times we want the exact answer. Okay, the third one is more difficult. Move the 25, x squared minus 9x, leave a space, equals negative 25. What is the factor? And it's 9 divided by 2, which is 4 halves, but you want to work this entire problem using fractions. So x minus 9 over 2. If 9 over 2 is my factor, what is my perfect square? 81 fourths. 9 times 9 over 2 times 2. So I add 81 fourths, and I add 81 fourths. And I don't want to do that in my head. Negative 25 divided by 81 divided by 4. Oops. This should be a plus. Math fraction. Negative 19 fourths. So negative 19 over 4. This is to the second power. So I square root. And I square root. And I get x minus 9 halves equals. Does negative 19 simplify? Kind of. It would be plus or minus I root 19. 19 itself is prime, but that negative will come out in the form of an I. And every time you do this with a fraction, the denominator will always be a perfect square. So this is over 2. So when I add the 9/2 to the other side, I get 9 over 2 plus or minus I root 19 over 2. And the common practice is, since they're both over 2, which will always happen, they'll both be divided by the same number, then we just make one big long fraction and put the 2 at the bottom. And we always write it in that order. Real number plus the square root version, or plus or minus the square root version over 2, or whatever the denominator is. Okay. Pull out your worksheet from yesterday. Go to the second page. I believe we have 2 problems to work on the second page. Are we on this one? Okay. So, the first one has a leading coefficient. That's going to totally screw up our complete the square. You cannot complete the square with the leading coefficient. The bad news is, if I divide by 2, am I going to get a quadratic without fractions? No. So if you're factoring it, remember, you take the 2x squared and the 5 and you multiply them together and you do that big long process. When you complete the square, you divide by 2, even if it doesn't work the way you want it to. So we end up with x squared minus 7x, and I'm going to move the 5 over, equals negative 5/2. And the only thing this is going to change is it's going to make there will be a few more fractions, but the system is exactly the same. Bottom of the second page. Does yours say, did you get an honors one? You see it? Oh, okay. So, when I divide by 2, does that change my graph? Yes. So my graph was an open parabola. By dividing it by 2, now it's twice as open. But the roots will stay the same. So as long as you're looking for the roots, you're allowed to multiply or divide by any number you want. All right. So, what is my factor? Well, it's half of 7, so 7/2. Okay? And then if 7/2 is my factor, what is my perfect square? 49/4. 7 times 7 divided by 2 times 2. Josie, are you catching up on this? Is this making sense? Okay, good. So plus 49 over 4 plus 49 over 4. So on my calculator, I have negative 5/2 plus 49/4, which gives me, oh, sorry, I want the fraction version, 39 over 4. So this equals 39 over 4. Take the square root, just like I did before. Does 39 simplify? 39 is 3 times 13. So can I pull anything out? No, doesn't have any pairs. So I get x minus 7 over 2 equals plus or minus the square root of 39 over 2. And once again, that denominator will always simplify. Okay, you're fine. So add 7 over 2, and these don't mix, so my answer is 7 plus or minus the square root of 39, and they're both over 2. Okay? The next one is as hard as it gets. So I have a leading coefficient of 8. It doesn't divide out nicely, but because I'm completing the square, I need to just go ahead and divide it. And keep all of your numbers in fraction form. So x squared minus, can 18 over 8 simplify? 9 halves. So minus, or 9 fourths, x. And I'm going to move the 82 to the other side. Does 82 over 8 simplify? 41 fourths. What if I don't know how to do that? Will my calculator simplify that for me? Well, just do 81 divide 8, math fraction, and it will simplify that. Yeah. Oh, 80, what is it? 82, sorry. 82 over 8. 41 over 4. So equals 41 over 4. Anybody confused up to this point? Now the trick is, what is my factor going to be? What is half of 9 fourths? Well, that's kind of tough. What's half of 1/2? 1/4. What's half of a fourth? 1/8. What's half of an eighth? 16th. So how do you divide a fraction by 2? Double the denominator. So half of 3/4 would be 3/8. Half of 7/6 would be 7/12. So all you need to do is double the denominator, which we really knew. What's half of 5? Well, 5 over 2, which is double the denominator, right? It was 5 over 1, then it turned into 5 over 2. So this is negative 9/8. So my perfect square is going to be 9 times 9 over 8 times 8. Yes? Yeah. No. Yeah, we're not. Okay, so 81 over 64 plus 81 over 64. So 41 fourths plus 81 64ths. Did I mess that up? That looks different from what I'm used to. Yes, that's why it looks wrong. So it's negative 41 fourths plus 81 fourths. Thank you. 81 64ths. Yeah, that's it. Negative 575 over 64. So my problem was that should have been a negative 41. So this equals negative 575 over 64. And notice the denominator is still a perfect square. That will always happen. So I take the square root. 575. We need to check to see if that factors. 575 is 5 times 115. 115 is 5 times 23? 23? Can I pull anything out? A 5, what's left? Can I pull anything else out? An I, because it's a negative 575. So x minus 9/8 equals plus or minus 5I root 23 over the square root of 64, which is 8. So we add the 9/8 to the other side, and we get x equals 9 plus or minus 5I root 23 over 8. And those are my roots. Oops. Okay, look at, let's see, look at the very last page. So, number 10, I'm going to need to divide by 9. What about number 11? What should I do with number 11? Divide by 2, okay, then what? Well, but this time it equals 2 instead of 0. Okay, you need to divide that one by 2 also, so it would become a 1. So when I'm solving quadratics, I need this to be a 0. But if I subtracted 2 and got a negative 6 equals 0, then what am I going to do? Then I'm going to move the 6 back over. So you might as well save yourself some time and just move this one. So you would divide by 2, and you do n squared minus 1/2. If I add this to that side, I'd get 6. So this would equal 3, and then leave a blank. Oh, there's an n right there. Okay. Your job today is to finish the rest of this worksheet. Good luck.